In this video, we are solving Bernoulli differential equations. So we have a Bernoulli differential equation right here. We want to begin by turning it into this form. So to do that, this is called an almost linear form. Okay, now we want to turn this into this. Divide by x on all of these terms. You get dy over dx plus 1 over x y equals 1 over x, and 1 over y squared is the same thing as y to the negative second power, so y to the negative 2. Okay, once you have this form, you want to then find w. And now, what is w? W is going to be y to the first power minus n. And we see here that this is n. The n here in this case would be negative 2. So it would be this. So to find w is equal to y to the 1 minus negative 2. Which means w equals to the y 1 plus 2, which is 3. So this is w. Let's put this aside. So w equals y to the third power. Okay? Now once you have that, you now want to find derivative of w with respect to x. Okay, so dw dx is equal to derivative of this, which is 3y squared dy over dx. Okay, now once you have this derivative, you want to solve for dy over dx. So dy over dx is equal to, divide by 3y squared on both sides. You get 1 over 3y squared dw over dx. Okay, now with this, you want to plug it into this. So this thing would be plugged into this portion. You have 1 over 3y squared dw over dx plus 1 over x y equals 1 over x y to the negative second power. Once you have that, you want to erase this to make more space. And if you can recall, when we did this, dw over dx is equal to derivative of this, 3y squared dy over dx. So you want to use this value and multiply it on all of these terms. So you will then have 3y squared times 1 over 3y squared dw dx plus 1 over xy equals 3y squared 1 over xy to the negative second power. Okay, now this and this cancels out. You're left with dw over dx plus 1 over x. Y squared plus y to the first power essentially is y cubed, so you get 3y cubed equals 3. Distribute this, you get 1 over x times y squared plus negative, okay, y squared times y to the negative 2 is the same as you add the exponent, so 2 added with negative 2 is 0, so you're left with only the constant, which is 3. So you have that, okay? Which you can turn it to dw over dx plus 3 over x y cubed equals 3 over x. Now that you have this, you want to substitute the w value, so this will become this because it's the same thing, okay? So it will be like this. Now that you have this, recall that this format is exactly the same as a linear equation. It is actually a linear equation. So from here on, you are going to solve this linear equation in order to solve this Bernoulli dE. So let's erase everything to make space. Let's okay. We copy this to put it right here. dw over dx plus 3 over xw equals 3 over x. So now that you have this linear differential equation, you want to solve it like how you would solve any linear equation. To do that, find the integrated factor. So the integrated factor, or IF, is equal to e to the integral of p dx. And p is going to be this value, 3 over x. So the integrating factor is equal to e to the 3 over x dx. And now 3 over x, the integral of 3 over x is going to be 3 ln x. Okay? And then you just add the e. Now, e to the ln power cancels out, so you can cancel it out. And then with this value, you're going to bring it to here and make it a power, okay? So you're left with the integrating factor equaling to x cubed, okay? Let's make a note of that. IF equals to x cubed. So with this, you want to multiply the integrating factor to all of these terms. So you are going to have x cubed multiplied by dw over dx plus 3 over xw equal to x cubed times 3 over x. Okay? Once you have this, you are going to put it in what I call the d form, the derivative form, which is essentially the derivative multiplied by this integrating factor value, which is x cubed times the w, okay? It does not matter if there's anything before the w, it will always be the integrating factor times the w, equaling to this thing. So x, well, I can simplify it. So it will be this 3x cubed over x, which this cancels out, this becomes a square. So it is derivative of x cubed times w equals 3x squared, okay? Now, what you want to do next is you want to find the integral of both these values. So integral of d derivative of x cubed times w equal to integral of 3x squared. And an integral of a derivative is same as this portion itself, because integral and a derivative cancels out. So you're left with x cubed times w equal to the integral of this. So whenever you do an integral, you want to add the value of this exponent and over the value. So it would be the same as 3x cubed over 3. So this and this cancels out, you're left with x cubed. Okay? But you're not done yet. With the w value, you want to substitute out the w for the original value, which is y cubed. So you are going to have x cubed y cubed equals x cubed. And then when you find the integral of this, you're going to add a constant, add c. So plus c. I should have wrote plus c over here. It would make more sense. Okay, so it's the same thing as this because we're substituting this in for w. Okay, so you have this. But you're not done yet. The last thing you want to do is you want to isolate the y value. So in order to do that, you want to divide x cubed on all of these terms. Therefore, you have y cubed equals x cubed over x cubed is a 1 plus, if you divide x cubed in the c term, it's the same as multiplying it by x to the negative 3. Okay, so you'll have c to the x of a negative 3 power. And this is your answer when solving this Bernoulli differential equation.